we can start. So last session, we covered one type of a genetic algorithm, then two architecture searches, which were much faster than a plain vanilla neural architecture search. And the ideas were parameter sharing and using continuous relaxation so that you don't have to decide between discrete choices. You can actually decide to put a weight on your discrete choices. And then in the end, you're going to prune it away. And these ended up being much faster rather than doing it in around 2,000 or 3,000 GPU days. You could do it in 1.5 to 4 days using a single GPU. Let's move on to EfficientNet. Any questions about EfficientNet? So this was an assignment for you to watch the video. Any questions about it? So the idea of EfficientNet, the big picture, is we always have this question: how deep should your neural network be? Or should we make our neural network deeper to get a better performance? Should we make it wider? Should we increase the resolution of the input and the feature maps that are going to end up from one layer to the next one? And this paper is going to answer it in a convincing fashion. It's not theoretical, but empirically, it is suggesting that you need to do all of them together. It's not enough to make your neural network only deeper and hope for the best. So you need to make it deeper, wider, and increase the resolution. And this belongs to the family of AutoML. Why? Here you don't have many choices. Here you only have 1, 2, 3 choices, which is going to be low dimensional. And then you can put a simple grid on this low dimensional space and then basically try out every single possibility on that grid and then find the best alpha, beta, and gamma. Unlike before that you had a lot of degrees of freedom, here you only have 3 degrees of freedom. And then the fourth one, you're going to reserve it to make your model bigger and bigger. Because once you find an efficient architecture, you're going to be able to scale it up. And EfficientNet is one of the best architectures out there these days. Any questions about it? Okay, in that case, we can move on. So in the next slide, I'm going to break this formula apart and tell you why they decided to choose negative 0.07. Where is that number coming from?